In the circuit diagram below, the battery has an EMF of 12 volts. Ignore the internal resistance of the battery. So here, our circuit here, we have a battery over there. We have two resistors connected in parallel, and that parallel combination is connected in series with this 4 ohm resistor over here. And then now this voltmeter here is measuring the voltage drop on the parallel combination. This is the voltage of the parallel combination. And this ammeter over here that we see here, that is in line with the battery, will be measuring total current there. Okay, now that's because it's an ammeter that is not within a branch, so it will read total current there. It's outside a branch there. Okay, now 9.2.1 says calculate the total resistance in the circuit there. Okay, now to do that, we must first calculate the resistance of the parallel combination first. So let's start. 9.2.1, 1 over Rp is equal to 1 over R1 plus 1 over R2. What we have here is we have 1 over 5 plus 1 over 3. And then let's get the fraction from the calculator. What we have for 1 over 5 plus 1 over 3, we have 1 over 5 plus 1 over 3 is giving us 8 over 15. So our fraction here is 8 over 15. Now the inverse of that, then we get Rp. The inverse of that is 15 over 8. Now on the calculator there, 15 over 8 is 1,875 ohms there. Now what do we do with this? Then we say that the total resistance is the parallel resistance plus the 4 ohm resistor, because they are now in series. They are in series. The parallel combination and the 4 ohm resistor, they are in series. So now once we have the parallel resistance, we are going to say 1,875 plus 4, and then we have 5,875 ohms. That will be the total resistance there. Okay, now 1 mark for the formula, the substitution over here, this answer over here, and then this answer over here as well there. That will be 4 marks for that one there. Okay, 9.2.2 says calculated the reading on the ammeter. Remember, the ammeter, that ammeter over there is reading the total current. So Ohm's law, current is equal to voltage over resistance, but then what type of current? Total current with total resistance and total voltage. Total voltage of the battery is 12, and then total resistance we got 5,875 there. So now in the calculator, 12 divided by 5,875, we have the 2,04 there. That means the total current of the circuit is 2,04 amperes there. 1 mark for the formula, 1 mark for the substitution, 1 mark for the answer with the correct SI units of amperes for current there. Okay, and then now 9.2.3, 9.2.3, calculate now the reading on the voltmeter. Now we must again ask ourselves, what is the voltmeter reading there? What voltage is it reading? It's reading the voltage across the parallel combination. So again, Ohm's law, current is equal to voltage over resistance. What type of voltage? Parallel for the parallel combination. What type of resistance? The resistance of the parallel combination. And then what type of current? Total current. That's because that although the current is splitting in that parallel combination, but then the whole current of from the battery goes into that section there, goes into that combination there. So it splits, but then as a whole, it's 2,04 that goes into this section over there. So now our current there is 2,04 is equal to, we are looking for the voltage parallel over the resistance for the parallel combination that was calculated over here is 1,875, and then this is over 1, let's cross multiply, and then Vp times 1 is Vp is equal to here 2,04, you have 2,04 multiplied by 1,875, giving us here a 3,825 volts there. That is the voltage for the parallel combination there. Okay, all right, then now calculate the power of the 4 ohm resistor there. Now when it comes to calculating power, there's a choice of formula that we must do. We must choose a formula whereby we have, number one, for the 4 ohm resistor already, clearly, we already have the resistance. So what else do we know about, what else do we have for that 4 ohm resistor? We have the current as well. Why is that? Because the current from the battery, the total current, flows through the ammeter over here, and then it flows through this 4 ohm resistor. Now, it only splits when it gets here. So it means it will not split until it passes the 4 ohm resistor. So we know that the current in that 4 ohm resistor is 2,04, the total current there. So now we choose a formula for power that has what? Current and resistance, which is power is equal to current squared multiplied by that resistance there. So the current that we have is 2,04 squared multiplied by a resistance of 4 there. So now we use this formula when we took this total current over here, because that 4 ohm resistor is in the same line as the ammeter and the battery, meaning it will get the total amount of current there. So we have current in that case there. So now is 2,04 squared multiplied by 4, giving us a 16,65 there. So we have 16,65 watts there. So it's going to be 1, 2, 3 for that one over there. So now 9.3 says, will the ammeter reading increase, decrease, or remain the same if the 5 ohm resistor is removed there? Now, the removal of a resistor, we must ask ourselves the question, what type of resistor are they removing? What kind of circuit are they leaving us with? There, adding or removing a resistor, are we getting more parallel or more series there? So if you remove that 5 ohm resistor over there, you see that our circuit will now remain a series circuit, whereby now our resistance will simply be 3 plus 4, which is 7. Compared to the amount of resistance we had when we had that 5 ohm resistor, we got 5,875. It means that if you remove the 5 ohm resistor, now we are left with a series circuit with resistors connected in series. Now, when resistors are connected in series, they give a higher amount of resistance. So now you start with saying that. Now let me start with the reason. The reason is that resistance increases. You remove parallel, you are left with series, the resistance increases. And this means that the current, the answer that they're looking for, the reading on the ammeter, will be decreases. And that's because current and resistance are inversely proportional. Current and resistance are inversely proportional. So therefore, if the resistance is going to increase by removing that one connected in parallel, leaving us with the series, that means that the current is going to decrease there. So in short, you remove parallel, you leave me with series, resistance will be higher. A higher resistance means a lower current, because they are inversely proportional, resistance and current there. And 1 mark for the reason, and 1 mark for the answer, and this will give us an activity out of 14 there.